This lesson is on graphing bar graphs. The standard is NC4MD4 to represent and interpret data using whole numbers. Our essential question is, in what ways can we represent and interpret data? Our students will know the difference between categorical data and numerical data, and how to interpret a frequency table, a scaled bar graph, and line plots. Students will be able to collect and represent and interpret data and apply computation skills, addition and subtraction, when asking and answering questions about data. So first, let's go over some vocabulary. A scaled bar graph is a graph that uses narrow columns, called bars, to compare different amounts. The scale is the number you count by on the axis. And on a bar graph, this number has to be the same the entire time. So if you're going to put an interval of 2, the interval has to be 2 the whole time. So you would be 2, 4, 6, 8, 10, etc. And just a reminder, when we're talking about the axes, we've got our x-axis that moves horizontally and our y-axis that is vertical. Now looking at some examples for drawing bar graphs. We're going to use this frequency table that looks at students' favorite foods, and we're going to turn it into a bar graph. The first thing we're going to need to do is label our axes. So I'm going to have food down at the bottom, and let me move that a little lower actually. And frequency or number of students on the y-axis. And I'm going to title my graph Favorite Foods. The next thing we need to do is decide on a scale. So I have frequencies of 6, 9, 12, 15, and 13. So I can do a number of different things. I can count by ones, I can count by twos, I might even be able to count by threes with the exception of 13. So let's do twos for this one. So I'm going to start with 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And then we can start constructing our graph. So I know that for pizza, I have 15. Well, that's not divisible by 2, but I know that it becomes right between 14 and 16. So if I'm going to make a graph for pizza, I know that it's going to be right between 14 and 16. So when I create that bar or that narrow column, it goes right up to 15, and then I can label it pizza. Next, hot dogs is 13, and I know that that is right between 12 and 14. And I'm using a different color because I have access to that, but you can also just skip a bar in between them to help keep yourself organized. Sandwiches are 6, and because we counted by twos, that's going to be right on a good interval. Mac and cheese is 12. And hamburgers is 9. Now 9's not on my interval over here, but I know that 9 comes right between 8 and 10. So now I have this bar graph, which is a great visual representation of my data, because if I want to know which one of them was liked the least, I know that I'm just looking for the smallest bar. If I want to know which one of them was liked the most, I know that I'm just looking for the largest bar. So this is a great visual representation of our data. Now we're going to look at an example that requires us to go from start to finish, creating our frequency table and creating our bar graph. So the question is, how many siblings do you have? And we have data points 2, 2, 3, 2, 3, 4, 1, 0, and 1. So when we're looking at the number of siblings, for 0, that 0 only occurs once. So the frequency is 1. That number 1 occurs twice, so the frequency is 2. The number 2 shows up 3 times, so the frequency is 3. The number 4 shows up once, so that frequency is 1. Oops, we skipped 3. And 3 shows up twice, so the frequency is 2. So that's what our frequency table would look like. And now we're going to create a bar graph with that information. We're going to title it. We can title it siblings. The number of siblings, or this X value, will go on the X-axis. And the number of students with that number of siblings will go on the Y. So this is numerical data because we're looking at the number of siblings that someone has. So we're going to have numbers on both axes, but it's important to remember that the frequency is going to go on that Y axis. So now I'm going to pick a scale, and I have 0, 1, 2, 3, 4. So that's going to be easy. I have a frequency of 1, frequency of 2, frequency of 3, so I don't need to count by any particular numbers. So I can start at 0, 1, 2, 3, 4, 5, and so on. Now the number of people who have 0 siblings is 1. So my bar is just going to go right up to the 1. The number of people that have 1 sibling is 2. So my 1 sibling bar will go up to the number 2 on the y-axis. The number of people that have 2 siblings is 3. So 3 students have 2 siblings. So my 2 sibling bar will go up to the 3. My 3 sibling bar will go up to the 2 because there are 2 students that have 3 siblings. And there's only 1 person with 4 siblings. So that's what my bar graph would look like in this instance. Turned out to be nice and symmetrical. Now we're going to look at some practice questions for interpreting that bar graph. The first question is, how many students do not have siblings? Well, we need to think about what it means to not have siblings. So not having siblings would mean 0 siblings. And we know from our graph that there was one student who has 0 siblings or no siblings. The next question is how many students have more than one sibling? The thing I need to think about here is that more than one does not include one. So more than one would be 2, 3, or 4 siblings. So there were 3 people that had 2 siblings, 2 people that had 3 siblings, and 1 person that had 4 siblings. When I add 3, 2, and 1, 3 plus 2 is 5, and 5 plus 1 is 6. So there were 6 students who have more than one sibling. The next question says, how many students have fewer than 2 siblings? Fewer is another word for less than. So I'm looking for less than 2 siblings. Well, that does not include 2 because 2 is not less than 2. So I'm looking for the number of students who have 0 siblings and the number of students who have 1 sibling. I have 1 student with 0 siblings and 2 students with 1 sibling. So that's 3 students who have fewer than 2 siblings. This last question says, how many more students have 2 siblings when compared to those who have 4 siblings? So I'm looking for the difference between the number of people who have 2 siblings and the number of people who have 1 sibling. Well, I know that there's 3 students who have 2 siblings and only 1 student with 4 siblings. Difference means subtract, and 3 minus 1 is 2. So there are 2 more students with 2 siblings than there are with 4 siblings.